Hey guys, so we're continuing with part 10 of the Regents Review series. It says base your answers to questions 4 through 7 on the diagram below and on your knowledge of earth science. The diagram represents several streams converging and eventually flowing into a lake. Points X and Y indicate locations on either side of a meander in the stream. Points A and B uh, indicate locations in the streams where stream discharge was measured in cubic centimeters per second. The circled region labeled C represents a depositional feature. Number 4. Identify the name of the depositional feature labeled C. The correct answer is delta. So any fan-shaped feature that a stream ends into an ocean is called a delta. You'll also find it in your Regents Review packet, page 8. Deltas look like this, and they form from streams ending into oceans. Number 5, in the box below, draw a cross-sectional view of the general shape of the stream bottom from points X to Y. So in this case, you have to figure out where you're having more erosion and where you're having more deposition, and then creating a cross-section of what the river looks like in the bottom of the river. So remember, wherever you can write down a capital letter D in a meander is where you have deposition, and the outer corner areas will be erosion. So you have deposition here in this case and erosion in these areas. In this case, for X and Y, you should have more deposition in Y, because you can write down a inverted capital letter D over here, and you have more erosion in X. Meaning in the X side in the bottom of the river, your river will be slightly lower, and in the Y side it will be slightly higher. Because X has greater erosion, more of the soil is being taken away from there and depositing in location Y. You'll also see this in your Regents Review packet, page 8. So you have lots of erosion in X and lots of deposition in Y, and it should look something like this. Number 6, describe how the size and shape of sediments will most likely change as they are transported downstream. Um, so you have a couple options. You can say for size, it can become small. The size can become smaller or decrease, and for the shape, it can become more rounded, less angular, and sharp edges are worn down. But you cannot say smooth, because even though it's smooth, smooth is not a shape. It's not asking for the texture. So when sediments get deposited or transported through rivers, there are becoming sorted by size. So the larger sediments get deposited first, then the smaller sediments get deposited later. And because they're being abraded, they're going through abrasion, meaning they're rubbing against each other and the soil that they're crossing through on the bottom of the river. They're getting smaller and smaller in size, and the shape is also getting rounder. Any angular surfaces are getting abraded or eroded as it's moving through the river. And if you go on your reference table, page 6, you can find the sizes of all the different types of sediments. Number 7, the stream velocity at location A is 100 centimeters per second, and the stream velocity at location B is 10 centimeters per second. Identify one possible particle diameter that would most likely be deposited between points A and B. So when it's talking about stream velocity and it's asking for the particle diameter, you need to go on your reference table, page 6. I'm told that location A has 100 centimeters per second velocity, and B has 10 centimeters per second, and I just need a possible particle diameter that would most likely be deposited anywhere between 10 centimeters per second and 100 centimeters per second. So here's 10 centimeters per second, here's 100 centimeters per second in the x-axis. If I go up and stop at the black line and go sideways, I see that my particle diameter can be any number in between these areas. So your answer can be somewhere between 0.18 centimeters around here to 2.5 centimeters around here. And that's it.